Hey guys, it's Mr. C here, and in this example, which is at the top of page 2 of section 4.7, I'm going to show you how to find a basis for not only the row space, but also the column space of a matrix A. Let me go ahead and get my pen ready. We'll start with the row space. Now what I want you to notice about this matrix on the left is that it's in row echelon form. It's not really the biggest deal in the world, but there are some things that we have to address when we have a matrix A and convert it to row echelon form or reduced row echelon form. On this example, we won't be worried about those details, but in the next video we will be, so hang tight for that. But since this matrix is in row echelon form, it's kind of an advantageous form to be in because the row space is going to have basis vectors, which are row vectors from this matrix containing any leading ones. So if you look at row 1, we do have a leading 1, and so row 1 is going to be a row vector that helps us to form the row space of A. So let's start with that. We'll write set notation. And row 1, since it has a leading 1 in it, is going to be a basis vector for the row space. So I'll write it this way. Bracket 1, 2, negative 1, 5. If you look at row 2, so row 1 had a leading 1, but row 2 also has a leading 1. So this entire row from the matrix A should also be part of the basis for the row space. So you want to include that in here as well. So the entire row, 0, 1, 4, and 3. And if you look at the third row, it too has a leading 1 in it. So all of row 3 is going to be a basis vector for the row space. So 0, 0, 1, negative 7. And that right there would be the basis vectors for the row space. Now the row space isn't just these three vectors, it's actually the set of all linear combinations of these three vectors, so it's a lot larger. Okay, but these would be the vectors that help to form that space. The column space is found by utilizing the leading ones as well. So here's how you decide on which columns to use. You ask yourself, is column 1 a column that contains one of the leading ones? And as you can see, column 1 does contain one of the leading ones, which helped us to form a row vector. So you are going to need column 1 as part of the column space here. 1, 0, 0. Column 2 doesn't start out with a 1, but it does contain a leading 1 that we used to help us form the row space. So because column 2 contains a leading 1, we're going to want to use column 2 as part of the column space as well. Or at least it'll be a basis vector for it. Column 3 doesn't start out with a leading 1, but it does contain a leading 1 from when we're trying to find a basis for the row space, or a basis vector. So column 3 is going to need to be a part of our basis for the column space. So negative 1, 4, 1. And that's all there is in terms of basis vectors for the column space, because if you look at column 4, none of these entries are a leading 1. A leading 1 that helped us to establish a basis vector for the row space. In fact, no entries in column 4 are a 1. So for that reason, we're not going to use column 4. So the basis vectors that help us to form the column space of the matrix A are exactly these three. Much like the remarks for the row space, these three vectors aren't the only vectors in the column space. As soon as we start to form the linear combinations of them, we get other vectors, and the set of all linear combinations of these three vectors taken in its entirety gives us the column space of the matrix A. Alright, so that's how you can find a basis for the row space and column space of a matrix A. I look forward to seeing you in the next video. Alright, take care.